we are very happy to have Mr. George Stevenson, Managing Director of Active Plan. He will share with us digital assets capture for facility management, assets management for assets with BIM or without BIM models, and introduction of COBE. Let me briefly introduce George to you. Apart from being the managing director of Active Plan, George is also the chair of BIM for Housing and the Golden Thread Initiative Assets and Survey Group. He's also the chair of the Golden Thread Task Force and BIM in Assets Management. BIM or Assets Management Consultant, Visiting Director of Middlesex University Master of Science in BIM program, and also the founding members of Zero Construct. So may I pass this stage to George and deliver your sharing. George, please.
Right, so what David's just shown there is fantastic. And what we want to do is make more effective use of it. And what I'm going to be introducing here today is Smart 360 Photos, and how we can use that to bridge the gap between BIM and asset management. Also, how can we transform existing records on existing buildings into digital twins? And overall, why are we doing it? Well, in many cases, what we're doing is we're trying to make buildings safer. And what I'm going to be encouraging you to do is perhaps join the Golden Thread Task Force that everybody's trying to achieve with this. So what's new about what we're offering? Well, what we're finding is that what typically is happening with the mandates, we've had the mandates in Britain as well for the last 10 years, 15 years. The challenge is that we're getting really good BIM data that includes CAD, COBE data, O&M information, and also increasingly 360 photographs, but they're not connected. In many cases, they're not connected, which means that it's very difficult to check and process them. And the result of that is that we need to pull things out of and create an ecosystem. So to remove the silos that we're currently creating, make sure that information can be easily integrated, that we can federate information. That means that it can then also, if it's machine readable, it can be automatically audited and also later connected in ways that the design team wouldn't have thought that asset managements need to connect things. So what we're doing overall is making things more searchable, more findable. And the mechanism that we do to do that is that we'll take BIM models. If the information's in the BIM models, fantastic. We extract it into an asset database progressively, which I'll show you in a second. But we can also take information that wasn't in the BIM models, maybe from schedules, and importantly, from 360 photographs. We can turn 360 photographs into some intelligence that makes it a lot easier for people to maintain the information. And what that does is really it brings together the 3D model and also records what was actually installed, because the 360 photographs then become that record of what was actually installed by creating them into practical and affordable as-built models. Now, as far as Active Plan is concerned, we've got lots of clients who are large building owners. We've also got a lot of facilities management companies as clients. We've got construction companies, and we've got a lot of technology partners as well. And what we're doing really here this morning is talking about how we do this rather than why we do it. So one of the things that we want to do going forward is understand why we're actually doing things. But the focus of this today is to share with you the technology that we've built that we'd like to have partners to work with on it. We've got tools to create machine readable asset information requirements and also manufacturer's product library data. We can then automatically validate that information and produce project and asset information models. And we've also got tools to coordinate procedures, maintenance procedures, installation procedures, and the digital asset capture enables us to pull information together so that help desks can have a much better record of what's been installed in the buildings. Within ActivePlan, we've got deep expertise in BIM. We've been doing it now for literally 40 years. And we've also, though, unusually got a lot of experience in asset management, same sort of time period. And more recently, over the last 5 years or so, we've built a lot of knowledge of reality capture, and we've got some great partnerships with companies like Open Space and the like. And because of that, we've got expert partners and software firms. You can see here some of the companies that we're working with who are contributing to the whole joined up golden thread process. We also need, though, to understand why. What's the purpose of why we're collecting all this information? As David was showing earlier, some really practical examples. And to do that, we've created an ecosystem of people who are willing to share information about problems that they've got and how they're solving them. So we'd like you to join that task force so that we can maybe address things like building safety. We can also improve productivity and have less reliant on skilled people. We obviously want to utilize skilled people, but we want to be able to use them to the best effect. AI is everywhere. We've been working on it now for 7 years, and certainly it's very much part of what we're doing. And there's some brilliant ways that we can use this for decarbonisation as well. The sort of traditional ideal BIM to asset management process that we've put together is that we can start with product libraries, information requirements coming from the client end, the clients validating the information progressively, and then we end up with something that's a proper asset information model. And that's the ideal scenario that I think we've all been pursuing. And the way in which we're doing that within ActivePlan is that we've created standard reusable auditable libraries. The information requirements, rather than being in documents, can then be used to automatically test to see if manufacturer's product information has got what's needed. We're an Autodesk developer, so we built integrations in with Revit and AutoCAD so that we can identify where things were installed, and also then connect information through to produce digital asset information models. This is an example. This is a university in Dublin. This is our integration with the Autodesk platform. Now, the important thing about here is that this is within our asset information model. So the data about the assets themselves can be held in the models themselves, but it doesn't need to be. So in this particular case, the information on that pressurization unit is actually in a SQL database in the cloud. So the manufacturers can access that information, as can the maintenance teams. They don't have to learn how to use Revit to be able to access the information, for example, on this pump. And the information about the pump is coming from a product library. And the unique thing about what we've done is made it so that we can integrate the 360 photograph. So the 360 photograph actually represents what was actually installed rather than what was planned to be installed. And this is a much more cheap and cost-effective way of capturing real information. But the important thing here is that those tags are not in the 360 photo, they're actually in the database. So therefore, we've got all of the information, the classification information can then be glued together in the asset database that comes through, in this case, from COBie. So here we've got the data that's come through in the COBie outputs, a lot of rich information that's been populated from manufacturer's product data, and it's all glued together automatically because of the COBie schema. So the standards that David was talking about earlier, as long as people are following those, we're able to glue things together automatically. In this case, we're actually interacting with the 360 photo. So you've got the database on the right-hand side there of what should be in that room. And what we're now doing is tagging them, and you see it's gone green now. We can also use this to identify things that weren't in the models. In this particular college, the schools probably bought the furniture separately, and therefore they want to use the 360 photograph and the asset data to do the tagging. So that's creating an asset list. Here's another example. We've got a range of different software applications, Open Space, the Autodesk suite, the plan maintenance software, but we're asking a very simple question. Where are the fire dampers? So we've made it so that this is all easily glued together and searchable. So when we're looking for fire dampers, it's all connected back to the manufacturer's product data through a product library. So we've got the information that's been collected once and put in the product library. So then any other location where that fire damper has been used has got that data. Here we're now looking at the simple interactive plan. So we can find things in a 3D model, but often FM managers prefer a simple view like this. And what we've also done here, which is a really clever thing, is we've tied it back to open space, back to the 360 photos. So when you click on that asset in the schedule, it takes it to the 360 photo and zooms automatically to where that item is in the building. Now, that makes it then easy to also tag it back to documents. So the certificates, for example, of compliance, and also the operating and maintenance information can then be tied back to the asset, the system, and the space. And what we've also done is made it so that that can also be tied back to which locations that same fire damper has been installed in, which buildings, and also tied it back to SFG 20, which is the UK maintenance standards. So all of this is glued together in ways that then means, from an operational point of view, the information is easily kept up to date by whichever software is being used. So what do we do about things that aren't modeled? The ideal process of BIM is that what we should be doing is building a digital model that then goes through into construction. But the reality is that quite often that information isn't being provided in a machine readable format. It's in the form of information in documents, and we end up with a data gap. And therefore, the only option really then is to actually do a manual survey to send people to site to find out what was actually installed. And that can easily cost £100,000. So we've got FM clients who have to commission those surveys, and they need the baseline information to be able to understand what they've got to maintain. How can we address that? How can we learn from what Reality Capture's doing in the commercial send? This is Sodexo, one of our clients. They're a large FM contractor. And what they do, they basically send relatively low-cost people to site just with a 360 camera. That's a Theta camera, probably £400. And they just go and take 360 photos. And then this is the clever thing. The important thing is that back in the office, the subject matter experts can access that without having to go to site and actually do the asset tagging. And those tags are being brought through from the asset database. So here you're looking at active plan, and we've got here the 360 photos. We've also got all the assets that have been tagged by subject matter experts who could be anywhere in the world. So we're looking for people perhaps in Hong Kong that can recognize assets and therefore do some of this tagging. This is a great way for us to bring together the expertise that you have in Hong Kong and also in the UK. And that's part of what we're trying to do with the task force. What we're also able to do is that particular pump, for example, we're actually tying that back again to maintenance information. So this is then used to populate App Maximo, which is their main system. So all of the information here is then coordinated from BIM to asset database to plan and preventative maintenance. So digital asset capture, what they've found is that it's 600% more productive, which is quite a staggering figure. That means that rather than them normally being able to do 160 assets a day, they're actually doing 1,000 a day. What they can also do is once they've got that information from a capture perspective, they can also use it to validate what's been provided, what they've been told they've got to maintain. And Atkins are now applying it for using condition assessments and risk assessments. The beauty of this is that what we're actually doing is providing a platform to teach new people. So we can teach new people and also AI. So this is part of what we're doing in Active Plan. We've done now 150,000 assets, and that's giving us good training material to be able to recognize that valve, for example. What we're also doing is using AI to extract information, machine readable information from product data. The product library allows us to encourage manufacturers to put their information into a reusable library, but we're also using AI to be able to extract the information that's needed about assets from documentation. And we've got a partnership with LRQA, Lloyd's Register, to validate that information. So if you're interested in getting involved in the 360 pilots that we're trying to put in place, maybe you want to get involved in doing some asset tagging, or you'd like to, you've got 360 photos that you've captured anyway, would you like to see those turned into information? If you scan that barcode and just leave your information, then we'll get back to you. Right. How can we do things with existing information? This is a large project that we've got on in London at the moment. Tower Hamlets are a large London borough, and they've got 78 high-risk residential buildings. What we did, we used something simple initially, and that's just take a spreadsheet of all their properties, read it into the Active Plan database, and that created for us data containers for each of those properties. And this is simple stuff, but very effective. What we also did, we commissioned surveyors to go and use LiDAR, in this case, this is a Navis camera, to create the spatial models. And those spatial models then also include 360 photos. And the team, again, they don't need to go to site to do that asset capture. They can identify where all the fire doors are, where all the safety critical measures are, the emergency lighting. They can also look at the information about where the lifts are, etc. And all of this is connected back to the master database. Systems or assets mentioned in the safety case report can be connected. So here we've got the spatial model, and the spaces themselves and the measures that are in there are actually located automatically from the CAD data. But a lot of this information may not have been added. So the specialists are able to go through and say what type of lift that is. And as they're tagging, it's actually creating, as I was showing you earlier, the asset database, which again, is a two-way connection between the schedule of all the assets and also where it is. So if we want to see where that particular smoke detector is, by clicking on the schedule, it zooms to the 360 photo. And again, you know, I'm reiterating this, but this is how smart 360 photos, or how 360 photos can be made smart. So here we've got a smoke vent there, and we maybe want to record what type of actuators on it. So that's added. We're then going there. We can see there's a smoke detector there. So if you can just imagine how much more time effective this is to pull together information. There we've got a dry riser, which the emergency services will want to know where that is. And we can then go back to the schedule, and then the emergency services can say, where is that dry riser on the 4th floor? And it zooms to it. So it means that their planning is much more easy. Another way of using the spatial model is to pull together information that's being captured for different purposes. So in this case, we've got these sensors that are in the building from a tracking of temperature, humidity, and we're tapping in using an API into their source of information. So what this is doing, it's actually bringing it into the context of the spatial model. So we're reading that information live from the sensor, but also bringing that back to the asset information model. So this asset information model is a SQL database with all of the endpoints and the connections that tie everything together. So here we've got information about the fire doors and also the emergency lighting, and whether the, this simple example, whether the batteries need replacing. And by findability is something that we're trying to encourage. So here, for example, in this building, we've got some fire zones. We've now represented those fire zones in the active plan asset information model. So we've got intelligent spaces. These are the data containers that I was talking about earlier, but they can be grouped and organized in accordance with the fire zones. So it means that you can very easily see which spaces are being protected by which fire alarm system. What we can also do, and this is really simple but very, very effective, you can turn on drawings. So you can put drawings on as backstops and then be able to move between them. It's not as clever as that all being in the BIM models, and we can read the BIM models. The BIM models are part of Active Plan, but this is a simple way of doing things just with existing drawings. And here we're seeing which spaces that are maybe dangerous from a fire perspective, what doors they're being protected with, whether it's a 60-minute door or a 120-minute door in that case. And also we can see it in the context of the drawings, the backdrop drawings. And we can also connect in the detail that the installer has collected as they were carrying that out. In this case, we're reading the information that was done by a fire stopping contractor. So they're using a simple, good application for recording what they've installed, and they put a pin down on an image of the floor plan. Now, in theory, that's great, but the problem is, if you want to know what fire stopping has been installed in a corridor, you've got to open up 10 or 15 drawings to see it. Now, by reading the information, Active Plan can read the locations of those pins on the drawing. We create COBie data from the PDF reports. And then that means we then end up with an interactive model. So here we've got where all the fire stopping is. So remember, this information hasn't been modeled. It's come from just a report, a PDF report that we did some data engineering on, not AI, just some simple data engineering to pull this information together. But now we've got something that is a fully coordinated set of rich asset data that has been collected by installation contractors and then can be used by the FM team. So it's a matter of looking at this as an ecosystem of different information that can then be used and reused and kept up to date. And because it's in SQL, it means it's very easy to tie back to the other applications that people may be using. And the effect that we're doing here is to take 360 photos and asset data, bring them together, and then we end up with smart 360s that can then be used to tie back to all of the great stuff that David was showing earlier and the teams will use. And also, we're not bothered what type of camera is used. It may be a low cost 360 camera, or it might be something really clever like the Leica or Navis cameras. We've also got partnerships with Open Space, Multivista, Hexagon, other organizations who this information typically is being captured for construction purposes, but we can reuse it. We can use it for validating information. There's a whole range of different ways that you can imagine being able to navigate your O&M information through 360 photos. And what we're doing is we're making it so that we can transform record information from something that's dumb to make it something that's smart, from passive to something that's active, for something that you would need a human to read and interpret to make it machine actionable. And it's really the building blocks for AI. So if you're interested in getting involved in that side of things, if you're interested in getting your existing buildings and your existing information and make that AI ready, if you scan that QR code and just let us have your information or contact details, we will invite you to a workshop that we're going to be carrying out on that. So where are we going with this? Well, in London, we've got serious regulation because it's being driven politically because of the Grenfell disaster where people died. And there's big threats of prosecution already happening. And part of that process is what's called the golden thread. So this is really looking at buildings in a joined up and holistic way. So again, going back to what David was saying earlier, it's a way of pulling together the information so everything is then machine readable. So here we've got a scenario where a fire breaks out in a kitchen, and what we need to do is stop the smoke from getting into that stairwell there. How do we go about doing that? Well, the main thing is having good compartmentation. And the fire doors may be perfect, but we've got to make sure that all the other measures that go to make up the fire compartment are actually sound. And the same with smoke control, detection systems. So this is what we call the golden thread, making sure that everything that should work is actually in place and working. And when you're then doing inspections, you need to look at things not simply as to whether that fire door is a good fire door. You have to look at what is it actually doing. So that door there is, again, protecting a stairwell. And then when other software is then used by different teams who are doing inspections, what we want to do is make sure that this is all federated and glued together. So what we've done with the task force, we've brought together people who are software providers, also surveyors, people with expertise, and they can then work together to come up with solutions that actually work and are tested. We then bring in client organizations who understand or that need that particular solution. And by bringing them together, we can end up in a situation where we've got something that's tested and works, and then we can then use that again with good classification and standardization. We can then pull these together to demonstrate something, to provide something that actually works and not is a broken down thing. So if you think you've got something to contribute to that. If you'd like to know more about what the Golden Thread Task Force is doing, then please scan that QR code and get in touch with us. We've actually got a group of people who are Golden Thread Task Force champions here in Hong Kong as well. So Coleman kindly arranged this for us, and Coleman's a great contact for you to follow through on this. We've also got Danny Ho from Open Space, Dave Nicholson from Turner and Townsend, Paul Sheedy from Unify IDs established an operation here. And obviously you can always reach out to me or Paul Oakley, who's coming on shortly. So we're going to be forming a Golden Thread Task Force in Hong Kong. So if you're interested in participating in that, then please get in touch. We're also going to run a meeting on Teams on the 10th of December. So if you're interested in that, then please get in touch. And finally, this is the Coleman's asked me to put this up. This is something again that you can give him some feedback for my session, and I think others are going to do the same. Thank you.
Thank you, George, for your presentation. Can you go back a little bit, the first page? Oh, never mind.
Oh, sorry, I can do that. Sorry.
Yeah, you can share your last page so that the audience can buy time to scan your QR code to give you feedback. Okay, that's great. So so on our audiences, please scan the QR code and leave some comment and vote for the presentation, or leave your comment or any topics that you're interested or any collaboration that you're interested. Please leave your comment through the QR code. All right. Okay, thank you. Thank you, George, for your presentation.